Hello students, welcome back to MathFace Java programming tutorials. In this video, I'll discuss string handling. Introduction, memory allocation by JVM in Java, built-in classes for string handling, uses of the built-in classes. String is a collection of alphabets, numbers, special characters, spaces, etc. That is sequence of characters. And the sequence of characters enclosed in double quotes are known as strings. These can be used for URLs, login and password, name of a person, name of a place or a thing, address, numbers which do not require computation such as telephone numbers and dates. Let's see memory allocation. Whenever a program is executed, a thread is created for public static void main. And memory is allocated by JVM in 5 parts. First one is method area, which stores the methods, stack memory, heap memory, program counter register, native method stacks. Let's understand stack memory followed by heap memory. Stack is created whenever thread is created. Thread means public static void main. And each thread has its own stack. It is a last in first out data structure or first in last out. If you see the picture, the last string which is placed at the top can be removed first. There is a reason for this. It stores all primitive data type variables and reference variables. Stores only variables and contents of primitive data types and only reference variables, but contents are stored in heap memory. The size of a stack is lesser than the heap memory. Faster access is possible. Memory is automatically allocated and deallocated for a stack. It grows and shrinks. Let's see an example. Public static void main is a thread created in which there are 3 variables declared. Int x is equal to 5, y is equal to 3, z is equal to 4. And if at all x is equal to 5, create another variable m is equal to 5 and some other statements inside if. For this, hypothetical stack representation is like this. X is 5, y is 3, z is 4, m is 5 on top of the stack. Once if construct is executed fully in those curly braces, m is out of scope, so it is removed automatically from the stack from top. Then let's assume there are 2 more statements. First statement calling add method followed by parenthesis and sending 2 parameters. Similarly, subtract method by sending x and y as parameters. What happens internally when add method is called? In the method area, public void add code is stored already and x and y are sent as parameters. X is sent to A, y is to B, and int C is equal to A plus B. The stack representation would be like this for add method. A is 5, B is 3, C is equal to 8. Once if the method is fully executed, the stack memory and method area, this add method, are not anymore present in the memory. Similarly, subtract method is called and AB contains 5 and 3, pass by value less than 34. X is 5, y is 3, so x goes to, the contents of x will go get stored in A, contents of y go get stored in B. C is equal to A minus B. So, in the stack, A is 5, B is 3, C is 2. Once if the method is fully executed, the memory is not there for stack, shrinks. And the entire main method is executed, so no longer the stack is in the memory. So this is about stack memory, created whenever thread is created, and each thread has its own stack, last in, first out, all primitive data type variables and reference variables. Size is lesser than the heap memory. Memory is automatically allocated and deallocated for the stack. Let's see heap memory now. Heap memory stores contents of reference variables. What are reference variables? Objects, interface, and arrays. Now let's see. Heap memory is bigger in size, but it is slow in access. It stores objects, interfaces, and arrays, the contents of objects, interfaces, and arrays. But the reference variables are stored in stack. We will understand this point. Then, in recent versions, static variables and methods are stored in heap memory. Heap area contains string collection pool, SCP, or string literal pool, SLP. To understand SCP, SLP, we have learnt stack and heap so far. And the objects in heap memory are removed by garbage collector, but not from SCP, that is string collection pool. Objects in heap memory are removed by garbage collector, but garbage collector does not remove objects which are stored in string collection pool. There is a reason for this. And SCP is empty at the beginning. Heap memory inside this SCP is there. Now, built-in classes for string handling. There are 3 built-in classes which are defined in java.lang package. First one is string, which is immutable. We cannot change the contents. Second one is StringBuffer, which is mutable. StringBuilder is also mutable. Let's understand what is immutable and mutable with the help of an example. We've created a string Java using string class. Now we want to reverse Java. Being immutable, when we try to reverse, reading from last using a for loop, and let's suppose we are reading in reverse order and storing in some other object. S2, let's assume. S1 is Java, S2 should contain the reversed string. But what happens is, because it is immutable, first one it stores in, let's say S2, creates another object because immutable, AV, points at AV, S2 points at AVA, points at AVAJ. So in between, 3 more objects are created because it is immutable. Every time we try to change, it creates a new object. Then StringBuffer and StringBuilder. Let's suppose Java is there and we want to reverse it. In that case, they are mutable. So what happens is A, then V, then A and J, only 2 objects because it's mutable. Now let's understand more about string. String is a built-in class. It is a non-primitive data type or reference type. It is a collection of characters. Starting index is 0, just like arrays. Exam is the string, then 0, 1, 2, 3 index. Immutable means contents of the object cannot be changed. Because cannot be changed or immutable, the strings are secure for login, password, and others. Then, in Java language, input is taken using built-in classes, for example, scanner or buffer reader. These classes internally use standard input stream, which is a collection of characters, that is string. So internally, standard input strings it takes, but these can be converted to other types like integers, real types, date types with the help of small built-in conversion methods. So internally, strings are taken. Scanner SC is equal to new scanner system.in, which we know already, uses standard input stream internally, and sc.nextInt converts to integer, next double converts to double, and so on and so forth. And there is another class, buffer reader, which we will discuss later. Readline is a method which reads a string, and parsent is a method, conversion method, which converts into integer. Integer dot parsent. Integer is a wrapper class, which we will understand. Now, apart from conversion methods, string class has several methods to handle strings. Before understanding all those methods, let's understand creating string objects. There are three ways to create string objects. First one is string as a literal. Literal means constant. Whatever is written within double quotes is known as a literal or a constant, which is stored in string literal pool or string constant pool. So string S1 is an object, is storing mail. So stack has S1, that is reference variable, whereas in the heap, that too in string constant pool, mail is created and S1 is pointing at mail, that is the gender of student 1. Then gender of student 2, female. S2 is in stack, female created in string constant pool. One object, one reference. Let's assume string S3 is also male. Then reference variable points at male, which is already created in string constant pool. Let's assume some 20 students are there. Male, female, all stack 20 variables. Reference variables point at only 2 objects, either male or female. That is why garbage collector does not deallocate objects from string constant pool. Why? Because let's assume S1 is deleted, but still S3 is pointing at male. So garbage collector does not deallocate objects from string constant pool. It deallocates object from heap area other than string constant pool. Now let's see the second way of creating string using new operator. String S4 is equal to new string Java. This kind of new operator creates the string in stack, the reference variable is there, but in the heap area Java is created. And S4 points at Java. Also, Java is a literal, so it also creates Java in string constant pool. So there are 2 objects here. One is in string constant pool, second one is in heap area. 2 objects, whereas in string literal, only 1 object. Then S5, another object we are creating. String S5 is equal to new string, but this time also we want Java or Bombay, some city. Organization is there, 4 branches in 4 cities, and all 100 employees belong to either one of those cities. So Bombay, Chennai. We can have like that. Now S5 is created in both the places again. One is in heap area, second one is string constant pool. But we can avoid from second object by using intern method. String S5 is equal to new string Java dot intern means check in string constant pool. If Java is already existing, do not redeclare the object in string constant pool, but not in heap area. Heap area, it has to declare. So what happens? Java, because of intern statement, string constant pool has only one Java. This is the second way, new operator. Third one is string from a character array. Character array. Array is a reference variable. So in heap area, A, B, A, C, array is stored. And grades is the reference variable which is stored in stack. And grades is pointing at A, B, A, C. From this, we can create a new string. How? String gr is equal to new string grades. We are sending an array as a parameter. And it is the constructor which is taking and converting into string, storing in heap area gr is equal to ABAC string. This is how we create string objects as a literal, as an object using new operator from character array. Now, uses of the built-in classes. We must know the difference among all these three classes, then only we will understand as a programmer which class to be created or which class object needs to be created for better performance. We know string is immutable, string buffer is mutable, string builder is mutable. Now string buffer is synchronized. Synchronized means two threads cannot call the same method of string buffer class, which may update the shared variable simultaneously. What is meant by this? Let's suppose there is some airline reservation is there. Two passengers are trying to book tickets for the same flight, and both of them came to know there are only 4 seats left. With the timestamp, passenger 1 initiated updating that shared variable. Of course, there is database and locking system, everything is there, but multi-threading environment where 2 passengers are trying to book the tickets. Update that 4 seats. First passenger wants to update in such a way, book 3 tickets. Second passenger wants to book 2 tickets. The first passenger, whenever he or she tried to update, the second passenger is not allowed to update till he or she completes the first passenger. Otherwise, there will be some overbooking happens. This is known as synchronization. Means 2 threads cannot update the shared variable simultaneously, one by one. String buffer is synchronized. String being a read-only type, it is thread safe. And string buffer, because of synchronization, thread safe. Whereas string builder, non-synchronized, means 2 threads can call the same method which updates the shared variable simultaneously. So it is not thread safe. It must be used in single threaded environment. So far we know immutable, mutable, mutable. String buffer is synchronized and thread safe. String builder is non-synchronized, not thread safe. So single threaded environment we use. And strings are used whenever there is a string which is not requiring changes, then we go for string class. String buffer is slower because of synchronization. And string builder is more efficient in single threaded environment. So keeping these things in mind, programmers create strings using either string or string buffer or string builder classes. Refer chapter 8 of Essentials of Computer Applications for further understanding and practice exercises. The next video is about methods in string class. Thank you.